Students, in the last video, we studied about this transformation of energy. Now, we saw that is how electrical energy is transformed into different forms of energy, and those energy can be transformed into electrical energy. Now, let us see this law of conservation of energy and try to understand it. So, in brief, I had told you that energy can neither be created nor destroyed. It can be converted from one form into another. Thus, the total amount of energy in the universe is going to remain constant. So, what is going to happen? That energy can neither be created nor destroyed. So, you can never, that is, you cannot create energy nor you can destroy it. But one form of energy can be converted into another form. And always remember that the total amount of energy is always going to remain constant in the universe. Now I told you that try this which is there, that has been cancelled. Okay, so no need to try that. So next one is, though you are not going to try this, let us understand it. Okay, tie the two pendulum to this horizontal thread in such a way that they will not hit each other while swinging. So what you are going to do, you are going to tie two pendulums. Okay, you have seen here, see, 1 and 2. Then what you're going to do, swing one of the pendulums and observe. So you're going to swing one of the pendulums and you're going to observe. So what is going to happen? You will see that as the speed of the pendulum oscillation of the pendulum slowly decreases, the second pendulum, which was initially stationary, begins to swing. Thus one pendulum transfers its energy to the other. So what is going to happen? See, you think you are going to swing this pendulum. Okay, so when you are going to swing this pendulum, this, when it comes and hits this other pendulum, okay, this will start moving. So slowly what is going to happen is the speed of this pendulum is slowly going to decrease. But as the speed of this pendulum is slowly going to decrease, you will observe that the speed of this pendulum is slowly increasing. So what do you infer from this? You will come to the conclusion that this pendulum has transferred, okay, this pendulum has transferred some of its energy to this pendulum, okay, and that is why the other pendulum will start moving. Now the next one is free fall. If we release an object from a height, it gets pulled towards the earth, isn't it? Yes, you know this. When you're going to that is throw, okay, any object from a height, okay, or you're going to just release, okay, any object from a height, what is going to happen? It's not going to go up, but it's slowly, it is going to come down. It's going to get pulled towards the earth. Why this is going to come down? This is because of the force of the gravitation. So see, an object falling solely under the influence of the gravitational force is said to be in free fall or to be falling freely. So if the force is only due to gravitational force, okay, if the object which is falling down is falling only under the influence of the gravitational force, then we say it is falling freely. Let us look at the kinetic and potential energies of an object of mass m falling freely from height h when the object is at different heights. Okay, so see, let us look at the kinetic energy as well as potential energies when the object of mass m, that means the object is having how much of mass? It's having mass m and it's going to fall freely, okay, from height h. So let us find out its kinetic energy and potential energy. So you can see here, okay, the object is here, okay, and it's falling freely, okay, on the earth, and the height of this is h. So at different points, what you are going to find out? You are going to calculate the kinetic energy and the potential energy. As shown in the figure, the point A is at a height h from the ground. So you can see here the that is this A which is there. Okay. Yes, it is at a height h from the ground, isn't it? So let the point be at a distance x. So this point which is there, this is at a distance x. Okay, this distance which is there, this is x. From A to B, the distance is x. Okay, and A to C, you can see the distance is h. Okay, let the point C be on the ground directly below A and B. So you can see this C point which is there, this is on the ground. Okay, so let us calculate the energies of the object at A, B and C. Now you know the formula, isn't it? Kinetic energy is equal to half mv square. When you don't know the formula, it's very easy to calculate kinetic energy and potential energy, isn't it? Half mv square. Then potential energy is how much? mgh. This is the formula for kinetic energy and potential energy. Now you want to calculate the kinetic energy at the point A. Then the stone was at rest, isn't it? The object is at rest when you are that is when it is falling from A. So at A initially the object is at rest, means the initial velocity is 0, isn't it? So okay, its initial velocity is going to be 0. Now here half mv square is half mu square, isn't it? Half mu square. Now u is 0, right? So half 0 into anything is 0. So here there is no motion at all. The object is at rest, means kinetic energy is going to be 0 and potential energy is going to be how much? See, here the kinetic energy is going to be 0 and it is going to have maximum potential energy, isn't it? So potential energy is how much? Mass into g, gravitation, into this whole height h, isn't it? Now total energy is how much? Kinetic energy plus potential energy. Now kinetic energy is how much? 0. Potential energy is how much? mgh. So 0 plus mgh is total energy is how much? mgh. Okay. So at this point, okay, at point A, the total energy is how much? mgh. Remember that. Now let the velocity of the object be vb when it reaches point B, having fallen through a distance x. Okay, so at a distance x, okay, it's having some velocity. No, now the velocity is not 0. It is having some velocity. So here, okay, let the velocity of the object be vb. Okay, so u is going to be 0, s is equal to x, okay, and A is equal to G. You can see here. See, this height which is there, okay, from here to here, it is x, right? And here G is gravitation. Due to gravitational force, it's coming down, isn't it? So, V square is equal to U square plus 2AS, okay? So, V square, here you have denoted velocity as VP, isn't it? Now, VP square is equal to, initial velocity is 0. When it started from the height A, the initial velocity was 0, isn't it? When it came to the point B, it had some final velocity. Now, see, V square is equal to U square plus 2A. Yes, now see here, U is going to be 0. A is what? A acceleration is due to gravity, right? So 2G, S is how much? Distance x, right? So VB square is equal to 0 plus 2gx. So velocity is equal to 2gx. Now just substitute, okay? You know the formula, half mv square, right? So here half m into v square is how much you got? 2gx. So kinetic energy is equal to half into m into 2gx, okay? That is 2 and 2 got cancelled, and you can see here this 2 and this 2, okay, got cancelled. So remains mgx. So kinetic energy is mgx. Now you will have to find out the potential energy. So height of the object when at B is equal to h minus x, right? This you know, the height of the object, okay, when from the ground to B, you know, this height, see. This is h and this is x. So this distance is h minus x. So potential energy is equal to mg into h minus x. So you know the formula, potential energy is equal to mgh. So h is how much? H is h minus x. So mg into h minus x. So potential energy, you know, mg is common over here. So mg into h minus mg into x. Now see, you will have to find out the total energy. So you found out at the point A, you found out the total energy. Their kinetic energy was 0 and potential energy was maximum. So 0 plus mgh was mgh. Now at the point B, okay, potential energy is equal to mgh minus mgx. Okay, so total energy is kinetic energy plus potential energy. Okay, now see, kinetic energy, how much you got? Mgx, just substitute here, mgx plus mg. Potential energy, how much you got? mgh minus mgx. So see, yeah, plus mgx and minus mgx will get cancelled. So what remains? Again, total energy is going to be mgh. Now see, you calculated the total energy at point A, and you calculated the potential energy at, you calculated the total energy at point B. Now you have to calculate the total energy at point C. So let me explain it to you. Let the velocity of the object be vc when it reaches the ground near point See, it's very simple if you understand. Okay. See, at point A, you saw the velocity was 0. Okay. Initial velocity was 0. Now, when it came to the point B, it had attained some velocity. Okay. So, you considered it as VB. Then, at point C, you are going to consider it as VC. Now again, you know, u was 0 because the object was at rest when it started from point A. So initial velocity was how much? U is 0. S is equal to how much? H. A is equal to G, isn't it? See, height is how much? Here, it is H, isn't it? And A is due to acceleration due to gravity again. So the distance is h, A is equal to g and u is equal to 0. So v square is equal to u square plus 2a. Yes. So vc square is equal to, you know, u is 0, just substitute, and as is gs. Now kinetic energy, okay, is equal to half mc square. Now, you know, just substitute half into m into v square is how much you got? 2gh. So that is equal to 2 and 2 will get cancelled again. So kinetic energy is equal to mgh over here. Now remember the kinetic energy, okay, it is maximum over here. So the height of the object from the ground at point C is h is equal to 0. So height at point C, okay, from the ground is how much? It is 0. Now potential energy is equal to mgh. Now just substitute, h is 0, isn't it? Now anything multiplied with 0 is 0. So mg into 0 is 0. Now again, here you can see at point C, the kinetic energy is maximum. Potential energy is how much? It is 0. So total energy is again, see, mgh. So from the equations 1, 2 and 3, we see that the total energy of the object is the same at the 3 points A, B and C. So you can see here the total energy at point A, okay, at point B and at point C is equal. It is mgh, isn't it? So the total energy is always conserved. Now see, thus every object has potential energy when it is at a height above the ground, and it keeps getting converted to kinetic energy as the object falls towards the ground. On reaching the ground point C, all the potential energy gets converted to kinetic energy, but at any point during the fall, the total energy remains constant. So you can see here, see at total energy at A, okay, the potential energy was maximum, kinetic energy was 0 at that time. So the total energy is mgh. Then total energy at B, okay, potential energy is mgx, okay. Then kinetic energy is mg into h minus x, but still you can see the total energy when you simplify is going to be mgh. Means here what happened, the potential energy, some part of the potential energy had got converted into kinetic energy. Now total energy at C, you can see all the potential energy has got converted into kinetic energy. That means potential energy has become zero here, and kinetic energy has fully, that is potential energy has fully got converted into kinetic energy. So you can see here the total energy at A is mgh again, total energy at B is mgh, total energy at C also is mgh.